And we're here at the IDTechEx show. And hi.
Hi, I'm Richard Ellinger with American Semiconductor. Some of you may be familiar with us, others that aren't. American Semiconductor takes standard silicon from the marketplace, like from NXP, Nordic, EM Micro, and we make it ultra thin and we make it flexible. We use polyimides from HD Microsystem to encapsulate the ultra thin die. We then dice them, put them on dicing tape, and deliver them back to your partners for assembly, just like they normally would receive. What this enables you to do is it enables you to take electronics and make them in ultra thin format, like this.
There's electronics
NFC,
in your business card?
Yes, NFC data logger. We have an RFID data logger here, completely thin. And we've even embedded the electronics inside this piece of corian for temperature assessment. You can track down to the final level for medication, down to each bottle, by utilizing flexible electronics. And what's most important is that we're here announcing that through our joint venture with HD Microsystems, we have put in a fully functioning, high volume production facility to produce high volume, ultra thin chips for the marketplace.
So, you taking the chips like Nordic or anyone?
Anyone,
is
doesn't
making?
matter.
Could be Marvell, it could be...
That's correct.
It could be Realtek, anything.
Any?
And you make them thinner.
That's correct. We make them thinner than a human hair.
How's that possible? You take away what's behind the chip and you replace it with something?
We take away what's behind the chip and we replace it with polyimides from HD Microsystems, which then gives you a fully encapsulated chip. So this chip is ready to be mounted onto a flexible substrate versus trying to use direct chip attach or actually using traditional chip packaging. So this allows you to put highly intelligent electronics wherever you'd like to put them.
So this is totally different from that one. The first one there.
This is the silicon wafer that you would get from Nordic.
Hey, can we see what's behind? So this bluish kind of stuff goes away?
Yes. This would be ground down.
How do you take it off?
Take it off multiple mechanical processes.
Like kind of scratch it off, something like that?
You grind, there's grind process, yeah, and there's multiple mechanical processes that you use.
And then
some are traditional in the marketplace to get thinner die, but no one takes them down as thin as we do. And then we take the polymer, top and bottom, and we'll put it on dicing tape like this and deliver it to the customer. This is just for trade show.
And what's behind there? There's nothing. It's transparent.
Correct.
So it's just
a
sheet of kind of like plastic.
This dicing tape here is a little sticky, and it's holding them in place, and you just use a pick and place machine to remove the die to place them down.
But is there a reason that they use this bluish? What is this bluish kind of stuff they use? Is that what silicon is?
Silicon. That is silicon. Yes.
Silicon Valley is full of this stuff, right?
Yes.
So it's the silicon. You take it off and you replace with plastic, and but isn't there there's something useful about the silicon, like in terms of performance or heat or something, or?
Well, its stability is the most important thing for the chip. Your individual die, if this is a die, for example, only the very, very top layer of the die actually has any active silicon in it. The rest of it is there for stability. So we remove all of that. We remove the non-active die, part of the die, and you're left with a very thin chip that actually can become flexible when you use the HD polyimides on top.
But if you make it flexible, does it break or something?
No, it doesn't. It actually becomes more durable. I'll give you an example. This wristband, I've worn this wristband for multiple trade shows for a few years, and this particular wristband is an intelligent wristband with an NHS 3100 chip on it from NXP, and what I have is I have an intelligent wristband that has my business information, so when I go to a show I don't have to carry cards. I can just use this wristband and show people my contact information.
So how about partnering up with all these Nordic and everybody to put it directly onto your, do you call it substrate? What do you call it?
To any substrate. The show on this side of the show has a tremendous number of flexible circuit board folks who are printing flexible circuit boards. They would be the ones interested in using flexible die on their flexible circuit board. First of all, it gives you zero height, and then also you can conform your electronics as well.
But this process sounds awesome, but what about just manufacturing directly on your substrate, on your plastic? Does that make sense? Or do you have to go through this process?
Well, you go through this process first.
Because that's the only way you mass produce the chips.
Well, this is how die are delivered. Traditional die are just delivered exactly on the same device. It's just that they're thicker. What we've done is we've made them very thin for the flexible industry, the ultra thin industry, to say this is how thin your die can actually be.
You can't flex like complicated ARM Cortex, something that's very high, or can you? What's the limit? So this is
ARM
ARM Cortex M0, NRF51. This is
has 256K
Nordic, right?
memory. It's a Nordic chip. The NXP chip. So yes, we can flex an ARM core process chip.
ARM Cortex M0, no problem.
No problem.
But the higher ones, the big ones, is there any point in doing that?
We haven't had a customer request it yet, but there's no reason we shouldn't be able to, based on the fact that we're not affecting what they've designed the chip to do. We're only removing the back. That's all we're doing. So removing the back that's not used. So we're not going to affect the performance of the chip or the function of it.
And this stuff that you remove in the back is kind of like sand, silicon, right? It's just sand.
There's
no need to recycle
silicon,
that part.
There's no need, no.
It's just a kind of cheap material, no? The silicon.
It depends on who's using it, yeah.
And what's the yield when you go from this to this? Does it stay very high?
Whatever the known good die are on this wafer, we deliver the same known good die back up to 99%.
It sounds like this could be, is it huge? Are you're already in mass production in products, right?
We're already in production. What's important is that we just put our production line in place, and it's now open and available for high volume production. We've before been doing in smaller runs. Now we have our production facility in place.
And I already saw this part of the video, but it's going to show...
it's going to come up with more activity.
With the more finalized setup, which is like ready for mass production. With all these machines, is this part of your recipe?
This is all part of it as well. And it'll actually show people working in it in a second if you wait. Yeah. That's just showing you the different rooms that we have available.
Where is this?
This is in Boise, Idaho.
All right.
It's coming up.
Is this your machine?
Yep.
Do you design those machines?
No. We buy machines from the marketplace just like everyone else.
And then you have efficient process. So
correct.
What's the price, kind of? How is
it's equivalent,
affordable?
or it's equivalent or less expensive than current packaging pricing for the market. So here's some pilot production activity that's going on in our facility today.
So is this going to revolutionize IoT and wearables and everything?
Yes.
Or what's happening? What's your plan? What's next?
The plan is to present this to the marketplace so they know it's available in high volume, and work and collaborate with others so we can flood the market with ultra-thin hybrid electronics.
Hybrid electronics is a great way to, because flexible printer electronics is awesome, but you need some hybrid for a while because you can't just print processors yet.
Correct. You don't need to.
Don't need
now
to.
You have processors that are ultra-thin, just as thin as the printed
nice.
IC.